This is a distance equals rate times time problem, and there's different varieties of these types of problems, so you have to be careful. Some use the formula exactly the way it looks, distance equals rate times time. There are other versions. You can solve it for t, and you get time is equal to distance over rate when you divide both sides by the rate, or you can solve for r, and you get the rate is equal to distance divided by time, miles per hour. When you have miles per hour divided by, miles divided by miles per hour, what you end up with is hours. So that would be time over there. All right, so these are the three related formulas to distance equals rate times time problems. So here we have two planes which are 3,325 miles apart, flying directly towards each other. Their speeds only differ by 65 miles per hour, so that means one's going faster and one's going slower. They're flying directly towards each other, and they pass safely. We don't want them to run into each other. Exactly 5 hours into their flights. So the problem is asking how fast is each plane going. We know that there's a 65 miles per hour difference, but we don't know exactly how fast each one of them is going. So probably the best thing to do is try to figure out what the commonality here is. So I usually try to draw a little picture. The first thing is one plane is starting from A, some city, and the other one is starting from B, and they're flying directly towards each other. So A is flying in this direction, B is flying in that direction. And one thing we know is before they even started, they're 3325 miles apart. So this distance between these two planes is that 3325. Now you can't assume that they're going to meet exactly in the halfway point, because that would only happen if they were doing exactly the same speed towards each other. And there's 65 miles per hour difference in them. All right, so the only thing that's common is that the sum of their distance, whatever they travel, they might meet, let's say here. So he would travel this distance, B would, and A would travel this distance. But those two green arrows would add up to 3325. So my unknown here is a little bit about the distances. So I can set it up as distance 1, maybe this portion over here, what A travels, plus distance 2, what B travels, so maybe this part right here. And this is going to equal the total distance apart, so that would be the 3325. So this gives us a relationship between the two planes right off the bat. Now notice neither of these have nothing to do with, the time. So we need to kind of switch it over into time. So let's look at D1. Distance is equal to rate times time. All right, so I haven't really dealt with the unknown here. What is the thing that we do not know? Well, one of the things we do not know is the speed of the slower plane. So I'm going to go up to the top and say, well, there's my x. Speed of slower plane. It could be speed of the faster plane. It really doesn't matter, but I think it's easier just to make it the slower one. All right, so if x is the speed of the slower plane, we'll let b be the slower one. Then a must be the faster one. Well, how much faster than the slower one? Well, there's this difference of 65. So we have that the distance 1 is the slower plane. No, I'm sorry, the faster plane. Therefore, the speed of the slower plane plus 65 miles per hour. So it's going a difference of 65 miles per hour faster. So rate for this guy is going to be x plus 65. Now the time, t, is in hours, and we know exactly what the time is. It's 5 hours into their flight. So this is going to be 5. And the same thing for D2, the second distance, the slower plane guy over here. He's going to equal the slower speed. Let's get rid of this 1 here. Where's my eraser? Get rid of that. That's just the formula. D2 is the slower guy, so he's going to be doing x miles per hour, but he's also going to be going at 5 for 5 hours. So with these two equations, we can substitute them into that one up there. So the first distance is this x plus 65 times 5. I'll switch it around. commutative property is always nice. And d2, the slower speed, is going to be 5x. And this equals the total distance of 3325. So it gives us a nice equation, one variable. All right, and we'll distribute a little bit, and we get 5x, plus 325, plus another 5x, is equal to our 3325. So let's see, combine like terms, and start solving your linear equation. Subtract both sides by the 325. Purple. So subtract 325 here. Subtract 325 here. Well, that's nice because it comes out even. So we're going to get 10 times the slower speed is equal to 3,000. So the slower speed after you divide by 10 is going to be 300. So this one is doing 300 miles per hour. The faster plane is doing 65 miles per hour more. So that would be 365 miles per hour. And that's the speed of both of the planes.